door is open, it sticks out into the space. Sometimes, if that's open parallel to your body, absolutely parallel to your body, right? That plane has swung out parallel to your body, for instance, okay? The front, the bottom, and the top of that door will be absolute horizontal on your drawing. See how it kind of cuts out right from the wall? It's not always that way. Sometimes it's at an angle, right? So you got to start thinking, like if it's turned towards me a little bit more, all of a sudden this plane is receding as it moves into the wall, and the front part of it's out towards me. That plane has done this, so that's where it gets tricky. This line and this line go to its own vanishing point somewhere on the horizon line, okay? And so you got to start approximating those angles, okay? It gets tough, okay? So what I suggest to students, if there's a class going on in one of those rooms and the teacher has the door open, go open it all the way, okay? You know, quietly, so that the door then, you have the doorway, right? And then the door is open and like pushed up against the wall, right? So that's a door that's opened all the way. And it gets real tricky because those doors kind of stick out a little. It gets complicated. So what I tell students, just focus more on the doorway than the door. Kind of imagine the door not even being there to begin with. You know, so remove it, kind of open it up all the way. Don't go close the door because the teacher might want the door open. If there's nobody in the classroom, just go close the door, and you're just drawing the doorway anyways, right? Okay. So, so eventually you'll put doorknobs on or whatever, you know, I guess what I'm saying, but simplify now. So yeah, put all the doors in, okay, if you can. But see them as just shapes or doorways rather than doors, okay? Oh, and verticals. Be careful about this because the verticals, somebody asked me yesterday if they could use a T-square for that, and that's fine, I'm fine with that. So any horizontal that's not moving away from you, you could use a T-square, make it absolutely horizontal. Any vertical that you're drawing is absolutely vertical, because what tends to happen is students will see, just one more thing here, like they'll see the angle of that bottom line, right? And here's what will happen to some degree or another when you draw the door. Some students, everybody's paying attention to me, I know it's dry, but pay attention. They might do that, or they might do that up here, I don't know. But they'll tend to start to tip these lines. The doors will start to tip in the direction that suits the student's psychological need to maintain a 90-degree angle here. Okay? Because everybody knows that a door goes straight up from the bottom of the wall, and that's a 90-degree angle. That's a right angle. Okay? So your knowledge of that as a right angle supersedes the need you need to engage, which is making that vertical. Okay?
You just explained Frank Gehry.
Oh, I did?
Yeah.
Why?
The architect.
Yeah,
did
yeah.
that. That's the way all his buildings look to me.
Oh, you mean with the tilts and the
Yeah.
angles and all that sort of stuff? Yeah, yeah, that's true. That's true. Yeah, that is like a Frank Gehry door or something, right? Yeah, yeah. We don't want that. Okay. Everybody understand why you're doing that, right? Because you see this line and you want to make that a right angle. So if you're doing that in your drawing, even the slightest bit, your drawing's off. Okay. This has to be absolutely vertical. One trick, if you don't have a straight edge, I say this endlessly, but students just don't kind of get it. To make sure this is an absolute vertical, it's got to be absolutely parallel to that vertical, the edge of the paper. So all you need to do, once you find its location, measure over with your ruler. Here's a case in point where you can use the numbers on your ruler. Let's say you measure from here to here and you get 8 inches and a quarter. You measure from the top of the line over to the side of the paper, and you should get what?
8 and a quarter.
8 and a quarter. That means that this line is absolutely parallel to that line. And it's absolutely vertical then. Okay? Same with a horizontal. If you don't think that's absolutely horizontal there, measure up, get the same measurement. Okay? There's a reason that they create the paper having absolute horizontals and absolute verticals at a right angle here, right? Because it sets the stage for us. It gives us a framework to work with it. Think about it. If you didn't have looking at a TV, a video screen, everything you look at in the world that is a flat image that's pretending to be three-dimensional has that framework on it. It has two horizontals and two verticals. So everything you see within that picture, whether it's a moving image or a still image, is a relationship to horizontal and vertical. That's the reason you can pretend that it's real three-dimensional space, because you're reading it relative to horizontal and vertical, subconsciously. Otherwise, it would just be like, it's the ground for you, right? You'd just be floating in space somewhere. You would have no point of reference. So that vertical and that horizontal are sacrosanct in terms of understanding perspective and the illusion of three-dimensional space on a two-dimensional plane. Okay, so that's why I'm being very specific about that in terms of verticals and horizontals, because it makes all these weird angles relevant. Okay. That makes sense? Okay. We'll have maybe we'll do a critique. We'll definitely do one at the end of the class today. Okay. So if you want to start over, fine. That will give you a lot of time to. We might do one mid class, but probably not. We'll probably work to the end of class.